Our next speaker is Thierry Duvanel. Thierry is a seasoned executive within the technology sector with 20 years of multidisciplinary management experience in highly technical environments. His core expertise lies in operation that require deep understanding of the critical business drivers across markets and industries. After exiting his last company in 2016, Thierry led the Startup Accelerator MESS Challenge in Switzerland, building up a program attracting over 1,000 startups each year. Wow. And supported by a large group of corporations. Since 2019, Thierry is in charge of the open innovation for the Buhler Group, the leading global food technology provider. So let's go. Thierry, stage is yours.
I hope you can hear me. Is it okay?
Yes, we can hear you.
Very good. So good morning, everyone. I'm very pleased to talk this morning before a pretty big audience, actually. I'm not the only one today. I'm together with my colleague, Dr. Beatrice Conde, who is our group food science officer, and we will share the presentation. So maybe let me start with a very quick presentation of who we are as the Buhler Group. It's a company which is 160 years old this year, about 12,000 employees. We make about 3.3 billion Swiss francs in revenue. Don't say it, but we will probably post a little less this year. You know why. We are present all around the world, 100% family owned, and very much focused on plant-based products because we manufacture equipment for all the big food manufacturers for basically transforming everything which is plant-based. So in other words, we have an activity which is spread across two different markets. We serve for the main part of our activity, the food technology market, by providing technologies to, as I said, the big food manufacturers around the world. And this contributes to about feeding 2 billion people every day on the planet. And something which is a bit outside of the topic of the discussion today is the second business that you see here on the right. But for the completeness, I think it's important to tell it anyway. We are active also in the transformation of very special materials with a strong focus on mobility and automotive, and this contributes in itself to about moving 1 billion people every day on the planet. But back to the topic of the day, we are very much looking at meat and seafood alternatives. We all know that the trend of leaving the animal as a factory for providing us with proteins is very much something that is on the menu everywhere. Plant-based meat, plant-based alternatives are everywhere. You have some of the big players here who are most of them our customers listed here. But if you look just at the numbers, it's important to see that the global market for traditional meat products is estimated to $1.4 trillion. We are used to talking in billions when we talk about market shares. Here is trillions. So even if you capture about 10% of this market in about 10 years, 2029, it's in itself a 140 billion market. So it just shows how big this opportunity is, how big the demand is as well. And this is very much setting the ground for all our activities. So in order to show a little bit more in details what we are undertaking as a activity to sustain this approach, Beatrice, my colleague, who will now tell you more about our approach, our technologies, and more specifically where we come from, because we are not only an equipment manufacturer, but we are very much a solution provider. So Beatrice, I leave it up to you, and I will change the slides under your control. Beatrice, we can't hear you.
Yeah, thank you, Thierry. I was muted. I will continue, and I got the comment that if we can expand the slides because they are seeing it small. you need to probably change it on the, it's the PowerPoint mode, huh? But in the meantime, I'll introduce myself. So my name is Beatrice Comde. I'm the Food Science Officer for the Buhler Group, and I drive innovation at the interface between science, technology, and business. And I'm 12 years with Buhler. Previously, I was in academia, and protein has been something I've been working basically all my career with. What are the key innovation drivers? That is where we start. So when we talk about technology and processes, we need to understand the value that we want to deliver. And it's all about satisfying consumers' needs and desires. That's going, as we heard, very much towards plant-based. On the other angle, we have new, alternative, sustainable protein sources that are becoming attractive. And we don't want to eat these proteins, just a spoonful of protein every morning, unless we do some kind of crazy sports nutrition. We want to have a good culinary experience and taste. The new protein sources, soy is still very, very much used. That's the traditional one, but the new trending ones are pulses, be it peas, lentils, but chickpea also, very interesting, obviously, in the Middle East. Emerging sources are coming from the tank, from the single cell, microalgae as an example, and more looking into the future, cultured meat, where the first product to come on the market will probably be hybrids, combination with plant-based. So it's all about delivering the taste experience. It's about convenience, nutritional performance, clean label, so working with as little components as possible, so which consumers also understand. The products need to be affordable. That's also one of the drivers, and obviously have a low footprint in terms of CO2, land, and water. Next. So Buhler provides solution in this space. And what sets us apart that we provide solutions across the whole processing chain. One key step of transforming proteins into meat alternatives is the texturing step, where the proteins are cooked under rather low moisture or a little bit more moisture, temperature and pressure. And they are transformed in so-called texturized proteins, where you change the microstructure in something which is more microfibrillar, resembling meat. So that is one of the key steps. But the secret of getting a good product starts, in fact, with the raw material and doing the right pre-processing, inactivating the nutritional compounds, enriching the protein that you need, getting rid of the compounds that create taste issues, for instance, enzymes. So preparing the raw material is an important step, and that's also where we provide solutions. At the end, this can go into all kinds of plant-based meats, burgers, but obviously also plant-based beverages, dairy replaces, which are very popular nowadays. Next. The technology which is used, and now I'm focusing more on the extrusion technology, is nothing new. The technology has been around since decades. It's a very well-known technology, and already in the 70s and 80s, the so-called TVP, textured vegetable protein, was quite popular, but it was less focusing really on the full experience. It was more focusing on delivering an attractive texture. So this is just images to show you, how these products come out of the extruder. Obviously, they still need to have a further confectioning into an attractive food product. Basically, we distinguish between two ways of processing the proteins into these textured proteins. One is the dry route, which is on the next slide. We call it dry because the end product is dry. So you take the proteins, you add little water, so less than 25%, so it's more a crumbly mass. You cook it under pressure in the extruder. You cut it as it comes out of the extruder, you dry it, and you have a dry textured product that is then later at home or in the food service rehydrated. Sometimes also this is done in the food industry. You can add flavors, you can add binding agents and produce, for instance, a type of burger that starts with the dry texture meat analog. That attractiveness here, you can do this quite high capacity, and also the product is shelf stable, but you're limited in the extent of fibrillarity that you can create and mimic really and come close to the meat texture. There is where the more modern wet textured meat analog come in. Again, it's basically the same machine, the same extruder. The difference is you work with much more water, so it's close to 40%. In fact, you melt the proteins in the extruder, and then you pass them through a cooling die. And in this step, the proteins which have unfolded and lost their globular structure are aligning into a fibrillar structure. And as you cool it down, you can basically freeze, you can get a kinetic stabilization of the structure. And you get a fibrillar structure which comes quite close to, for instance, a chicken type product. This obviously then needs also still to be cut. Flavor can be added in extrusion or afterwards. Maybe you also want to add micronutrients, for instance, iron or vitamin B. The product here is not shelf stable. It needs to be frozen. The alternative would be to pasteurize it and then keep it in refrigerated storage. Now the products look, I'll give you an example, it's on the next slide. It's a chicken chunk that can be produced with this technology and looks and feels very similar to a chicken structure. Obviously, the taste needs to be imparted by adding the right flavors or creating, this flavor even in the extrusion process. This is one type of product which is very attractive on the market, and typically more downstream. It's prepared also using all the global new culinary trends. It can be from a curry really to all kinds of exotic dishes, but also the more traditional ones that we know in the Western world. Now, if we think of the cooling die, there is where we have invested quite a lot of science and technology to develop that. That is the cooling die, how this mass looks when it comes out of the cooling die. This is a small one. This is more for lab applications. And this is the far larger one where you can get up to 500 kilogram per hour, where we are market leaders at this capacity. So if you run an extrusion process at this capacity, you get close to 3,000, you can say, chicken breasts per hour. So that becomes really very attractive then to serve the market also with affordable products and come up with attractive alternative for consumers, especially if you're good also in downstream confectioning this into attractive products. Our expertise goes beyond doing the technical side of things and designing processes to design food. It's also to bring the comprehensive understanding, and that's why we do life cycle analysis. And this is a comparison of the CO2 footprint of meat analogs and meat. And it's not a surprise to see that meat analogs are 10 to 20 times more efficient than real meat. But if you compare meat analog 1 and meat analog 2, the difference there is the starting raw material. In the second case, with a little bit higher footprint, you start with a protein isolate, which is highly concentrated, while in the first case, you start with a concentrate, a less refined material. And that's the path that we need to take into the future. Start with less refined material to make more out of the raw materials, and also incorporate valuable aspects like the fibers, because that is what we really lack in our nutrition today. So this is a way to minimize side streams and reduce waste, but you can also look at it from the other angle and say, how can we leverage side streams and also protein-rich side streams to use them as raw materials for plant-based meat? And we have an example here showing, and this is obviously the intermediate product. It's not the final product as it looks then on the fork for a consumer. But you can use, for instance, apple pulp and combine it with pea proteins, or algae and combine it with pea proteins. Brewer spent grain is very attractive because it's quite rich in protein, and also in fiber. The same holds true for soya expel cake or all oilseed press cakes, which are very high in protein and where today not enough value is created from this side stream. So it's a very attractive starting point that can well be combined also with other proteins. And you will see on the next slide an example how brewer's spent grain can be valorized. So this is a kind of samosa where 20% of the ingredient is brewer's spent grain combined with soy protein and then further confectioned into a kind of minced meat product. Very attractive in terms of culinary experience, health, obviously sustainability. It's a vegan product, it's a whole storytelling, and it's a very global product in that sense. There are also other examples which are far away from meat, like this cereal bar, where it's becoming attractive on the market to have high protein cereal bars. One downside is that when you try to add a lot of protein, you create a sandy texture. And there it can be very attractive to pre-texture the protein and add it at little, for instance, crisp pieces. And by that contribute also to an attractive texture and avoid the undesired sandiness. Also, our work goes into understanding new raw materials. Microalgae will be the materials of the future. Here we do research together with academia, and you see some examples how we have incorporated more and more microalgae and also played with the recipe in terms of moisture and combining it with other proteins. And obviously also understanding to which extent we open up the structure in the extruder or if we keep it closed. So there's a lot of ways really to play with extrusion technology and design different types of product textures and product functionalities. So at the end, it's all about collaborative innovation. And because the big targets that we have to contribute to sustainability and create an impact, we cannot do alone. At the end, we are the enablers through our technology to create impact through our customers. Here on the left-hand side, I show you a consortium, 8 players. It's an EIT food project aiming at building the next generation of plant protein foods, where all the players, seamlessly integrate really from raw material to consumer-facing player and designing, in fact, the solutions from a very consumer-centric perspective and tuning the technology for this purpose. Also in Switzerland, we have several initiatives to build the science and technology that we need to be always at the forefront and delivering the solutions that the market requires. And assets that we have are our application centers around the world. We have application centers, big ones here in Utzwil, in China, in North America. The latest one we are opening together with Givaudan in Singapore. So there we are also exploring new partnerships to enable the markets to get access to this kind of infrastructure. It's not only the application center where products can be produced at the smallest industrial scale to test the technology, but also to do samples for the market. It's also complemented by analytical capabilities, chemistry, physics, microscopy, to really monitor the performance of the product as the products are developed and designed. In that sense, that is infrastructure that we also offer to our partners, because only by really playing together here in these places, we can deliver also innovation. And with that, I come to the end to the presentation, and Thierry and myself, we are very open to take questions. I cannot hear anything.
Neither I. There's no questions.
Can you hear me now?
Yes, we can hear you. Yeah.
Oh, great. So thank you again for the Buhler team, a great presentation. Thank you, Thierry. Thank you, Beatrice. It was amazing to see your work, and we really thank you for addressing the local Israeli attendees. We invite you to join us also next year in hopefully live post COVID-19 period here in Israel, and to explore the advancement of the cooperation between Switzerland and Israel. We had some questions from the audience. Can you hear me?
Absolutely.
Yes.
Okay, so this is the first question. Considering the overall timeline for developing a novel plant-based product, where is the biggest effort in your opinion?
If somebody comes with a clear idea of what they want to have, for instance, they say, this is the raw material, this is the format of the product, this is how I want to serve the market, etc., then I would say it is quite straightforward. And working in our pilot plans, I say in 3 weeks, you have a concept which is very clear and proven. And then obviously then it needs then to still develop so that you can implement it into the market with whatever it needs as assets. But I think defining the concept is a key step, but also understanding the supply chain in terms of raw materials. What do you need in terms of raw materials to get to the goal? Sometimes it sounds very easy. Yeah, I'll get protein isolate. If you work with soy, these products are very, very well characterized, and there's a lot of knowledge around it. But if you start, for instance, now with chickpea, it's extremely interesting and attractive, but there is still less science around it. So probably there needs then to be invested a little bit more in what does it mean into the upstream processing to really tune it for these new applications.
Thank you for that. Next question, Thierry, are there any underestimated challenges that you see in developing plant-based new products?
Well, I can take this one. Maybe I think it relates to what Beatrice said before. It's very much the scaling up. We see that with many young companies and startups developing small scale, and I'm not even talking about lab scale, but even few kilograms is something that is relatively easy with the support of the skills and the technology centers. But when it comes to really making sure that you can scale up in terms of supply of raw materials, ensuring consistency, stability, and similar specifications, so that you don't have any alteration of the end product, it's very, very important. And with new products that are being developed, this is probably maybe not something that is consistently underestimated, but this is a challenge that needs to be well thought through ahead, because we plan for failures, but we need also to plan for success. And success means increasing by several folds the intake of raw materials, and this is not always super easy to manage.
Thank you. Last question. What are the predominant trends that you see in the market?
On one hand, it is using new protein sources, going beyond the traditional soy and gluten, although, by the way, gluten is a fantastic texturing agent. With very little, you can do a lot, but, it's apart. Also, the new proteins coming out of the tank. But I would say also, apart from meat, and that's maybe also addressing one of the questions that I'm just seeing on the chat, is also seafood. Fish. Let's not forget that worldwide aquaculture, is the part of the animal food chain, which is strongly growing. And making this more sustainable needs different angles. And one angle is to have replacements, for instance, for tuna. Tuna is a good example, where we very often eat the tuna in a creamy way. We don't even imagine the fish in a sandwich. So that's something that can very well be replaced by this kind of, textured protein, and a very attractive product can be created. So I would say looking beyond traditional meat and looking also at the whole spectrum of seafood.
Okay, thank you very much for the presentation and for the answers. It was a pleasure to have you with us. I wish you a pleasant day, and thank you again. It was amazing.
Thank you. Thank you for the invitation. And
Thanks
next year we will be there live.
Yes, for sure. We'll have
Good.
cultured seafood together next year.
Super, exactly, yeah.
We hope so.
Let's take that as a vision. Good, bye-bye.
Have a great day in Israel. Bye-bye.